So what we're going to look at is, okay, so you see that big dip at 1700 on the IR spectrograph?
Yep.
So that tells us a carbon to oxygen double bond, right?
Yep.
So if we look at about 2720 around here, if this was a aldehyde, we would have a little extra bit on the end.
Yeah.
Here at about 2720, roughly to 3100. We have a bigger bit here. We know it doesn't have any hydrogen bonding because you've got no peak on the left.
Yeah, so it's a ketone.
So it's a ketone. So we can look up here and we see for our, oh my gosh, my brain. The top graph, because that's good science. We see the highest M to Z ratio is 86. So that tells us that the molecule has a molecular mass of 86. So it's a ketone with a molecular mass of 86. We can tell, I mean, you can kind of tell that it's going to be an aldehyde or a ketone by the question itself, by the formula that it's given. C5H10O. And then you just, yeah, the molecular formula is C5H10O, which would be what? What would the name be?
It would be pentanone.
Pentanone. Perfect. It's super easy.
Double bond just goes, when you're drawing ketones, the double bond just goes in the middle, right?
Yeah, I would draw it like the second carbon in from the left, just for but yeah, these questions are easy because they give you the formula, so you can narrow it down. You can look at the formula and narrow it down to a very small number, and then you just look at the mass spec.
Yeah.
So here we've got a fragment at 71, which is CH3, CH2, CH2, CO plus. But again, if they've given you the formula and you can deduce the mass, then you'll be fine.
Yep.
All right, stop that.